In this video, I will discuss the chemistry of hydrogen. Hydrogen was first isolated and recognized as a distinct element by Henry Cavendish. But hydrogen was named by Anton. Lewis named it hydrogen because it burns in air to produce water. Water producer. Hydrogen is an unusual element because it doesn't fit perfectly into any group of the periodic table. However, it is placed in group 1 not because it's an alkali melter, but because its electronic configuration resembles those of the alkali melters. The electronic configuration of hydrogen is 1s1. That's one valence electron, just like the alkali melters. For example, the electronic configuration of lithium is 1s2, 2s1. While that of sodium is 1s2, 2s2, 2p6, 3s1. So the alkali metals have one valence electron, and so does hydrogen, which is why hydrogen is placed in that group, on top of the group. Hydrogen can also behave like the halogens by accepting electron to form hydride ion. Although it doesn't accept electron easily like the halogens, but when it does, it has two electrons in its outermost shell. And so it resembles the duplet configuration of helium. Now, isotopes of hydrogen. Isotopes are atoms of the same element with the same atomic number but different mass number. Hydrogen has three main isotopes, which are protium, deuterium, and tritium. They have the same atomic number but different mass number. Deuterium is chemically similar to protium, but it is less reactive, while tritium is radioactive. Protium forms an oxide H2O, which is water, while deuterium forms an oxide D2O, which is called heavy water. It is called heavy water because it is about 1.1 times heavier than water. So those are the isotopes of hydrogen: protium, deuterium, tritium. Don't forget that tritium is radioactive. So that's for the isotopes of hydrogen. Now the oxidation number of hydrogen. It has an oxidation number of +1 in most of its compound, except in ionic hydride where it is -1. For example, in compounds like HCl, NH3, the oxidation number of hydrogen is +1. HCl, X plus -1. The oxidation number of chloride ion is -1, so equals to 0. X -1 equals to 0. X equals to +1. So the oxidation number of hydrogen is +1. In ammonia, NH3, the oxidation number of nitrogen is -3 plus 3x equals to 0. 3x equals to plus 3. S equals to plus 3 over 3, and that's +1. Now, in ionic hydride like NaHCAH2, the oxidation number of hydrogen is -1. Now, in sodium hydride, the oxidation number of sodium is +1. So, +1 plus x equals to 0, S equals to minus 1. In calcium hydride, the oxidation number of calcium is plus 2. Plus 2 plus 2x equals to 0. 2x equals to minus 2. S equals to minus 2 over 2 equals to minus 1. So that's it. In most of its compound, it is plus 1, but in ionic hydride only, it is minus 1. For the preparation of hydrogen, we have the laboratory preparation and the industrial preparation. Starting with the laboratory preparation, there are three methods commonly used to prepare hydrogen in the laboratory. The first is the reaction of zinc with dilute strong acid. Can react with dilute strong acid like HCl and H2SO4 to produce hydrogen gas. The second method used is the reaction of sodium with cold water. For this reaction, you have to use a very small piece of sodium because sodium reacts violently with water. So you have to be very careful. The third one is the reaction of hot iron with steam. Iron at red heat liberates hydrogen from steam. So these are the three methods commonly used to prepare hydrogen in the laboratory. One, zinc with dilute strong acid like HCl and H2SO4. Two, small piece of sodium with cold water. And three, iron at red heat with steam. So these are the three methods commonly used to prepare hydrogen in the laboratory. For the industrial preparation, we have two methods. The first one is the Birch process, which uses water gas to produce hydrogen, while the second one is the use of methane to produce hydrogen. So starting with the Birch process, the raw materials are coke and water. When steam is passed over red hot coke at about 1200 degrees Celsius, a mixture of carbon monoxide and hydrogen gas is produced. This is water gas. This reaction is endothermic. Now, you can produce more hydrogen by passing excess steam over this mixture in the presence of a catalyst, usually iron 3 oxide. Give CO2 plus more hydrogen. This reaction is exothermic, while this one is endothermic. To get only hydrogen gas, you have to remove this carbon dioxide. You can do that by dissolving this mixture under pressure. So you will then get only hydrogen. But you may have some unreacted carbon monoxide, and you can remove that unreacted carbon monoxide by passing this mixture through ammonia gas solution of copper 1 ethanoate. So this will remove the unreacted carbon monoxide. So you are left with only hydrogen. So this is the Birch process. The second method is the production of hydrogen from methane. This method is cheaper than the Birch process because it uses natural gas, which consists mainly of methane. When methane and steam is passed over a nickel catalyst at about 800 degrees Celsius, a mixture of carbon monoxide and hydrogen is also produced. Methane is CH4 plus steam. Nickel catalyst, 800 degrees Celsius. CO plus H2. So this is the reaction. A mixture of methane and steam passed over a nickel catalyst at about 800 degrees Celsius to give carbon monoxide and hydrogen gas. You can remove the carbon monoxide by passing this mixture through ammoniac solution of copper 1 ethanoate, just like we did in the Birch process. So that's for the industrial preparation of hydrogen. Apart from those two methods, pure hydrogen can also be obtained as a byproduct in the electrolysis of brine. Electrolysis of brine is used to manufacture sodium hydroxide and chlorine. So hydrogen is a byproduct in this electrolysis. So that's for the industrial preparation. Birch process, which is from water gas, from methane, and from electrolysis. The next thing is the physical properties of hydrogen. One, hydrogen is a colorless, odorless, and tasteless gas. It is neutral to moist litmus paper. It is relatively insoluble in water. It is the lightest known element. 14.4 less dense than air. It has a very low boiling point of minus 253 degrees Celsius. That's very low, even closer to the absolute zero temperature. Those are the physical properties of hydrogen: colorless, odorless, and tasteless, neutral to moist litmus paper, relatively insoluble in water. It is the lightest known element and it's about 14.4 times less dense than air. And that's a very low boiling point of minus 253 degrees Celsius. Now, let us discuss the reactions of hydrogen. Hydrogen combines with some elements to form varieties of compounds, starting with the reaction with melters. Hydrogen reacts with very electropositive metals like the group 1 metals and the heavier group 2 metals to form ionic hydrides. For example, sodium reacts with hydrogen to form sodium hydride. Calcium, which is a group 2 metal, also reacts with hydrogen to form calcium hydride. Another reaction of hydrogen is with oxygen. Hydrogen bonds with a pale blue flame as it combines with oxygen to produce water in the form of steam. Another reaction is with halogens. Hydrogen reacts with halogens like chlorine, bromine, fluorine to produce halides. Example. This is hydrogen chloride. It can also react with bromine to form hydrogen bromide, with fluorine to form hydrogen fluoride. So these are the combinations reactions of hydrogen. We also have the reduction reaction of hydrogen. For the reducing action of hydrogen, hydrogen is a strong reducing agent mainly because of its high affinity for oxygen. It is capable of taking oxygen from some oxides, thereby reducing those oxides to the respective melter. It is capable of reducing the oxide of copper, zinc, and lead. For example, when copper 2 oxide is heated with hydrogen, it is reduced to copper melter, while the hydrogen is oxidized to H2O. Reduction is the loss of oxygen. So copper Two oxide loses oxygen, so it is reduced to copper melter. While the oxidation is the gain of oxygen, hydrogen gains oxygen, it is oxidized to tin. Another example is iron, reduction of iron 3 oxide. Iron 3 oxide is reduced to iron, it loses oxygen. Why? The oxygen is accepted by the hydrogen. Hydrogen gains the oxygen, so hydrogen is oxidized to tin. So that's the reduction action of hydrogen. Now, to test for hydrogen, insert a lighted splint into a test tube containing the unknown gas. If it burns with a squeaky pop sound, the gas is hydrogen. So that's basically the test for hydrogen. Burns with a squeaky pop sound. The next thing is the uses of hydrogen. One, it is used to manufacture ammonia through the Haber process. About half of the hydrogen produced yearly is used in the manufacture of ammonia, which is also used to make fertilizers. Ammonia is used in the production of fertilizers. That's why. Two, hydrogenation of vegetable oil. Hydrogen is also used in the hydrogenation of vegetable oils in the presence of naked catalysts to make solid fat like margarine. Three, it is used as fuel like rocket fuel. Four, it is used in the oxy-hydrogen flame for welding and cutting of metals. So hydrogen is used in oxy-hydrogen flame, oxygen, hydrogen, oxy-hydrogen flame for welding and for the cutting of metals. It is also used in the production of methanol. So hydrogen is used in the production of methanol. And it is also used in petroleum refining. So these are the main uses of hydrogen. Manufacture of ammonia, hydrogenation of vegetable oils as a fuel, in the oxy-hydrogen flame for welding and cutting of metals, the production of methanol, and in petroleum refining. Another use of hydrogen, which is less common nowadays, is in filling balloons. But there's a problem with that. Hydrogen is highly flammable, so it is less common. It is not used to fill balloon again, especially since the Hindenburg disaster, where the passenger airship catches fire. So hydrogen is less used in filling balloons. So these are the main uses of hydrogen. The next thing is hydrides. We have three main types of hydrides. We have the ionic hydrides, we have the covalent or molecular hydride, and we have the metallic or interstitial hydride. So starting with the ionic hydride. These are formed when hydrogen reacts with very electropositive melters like the group 1 melters and the heavier group 2 melters. Examples of ionic hydrides are sodium hydride, calcium hydride, and potassium hydride. These hydrides are usually crystalline solids with high melting point, and they are very good reducing agents. They can react with water to produce hydrogen. For example, calcium hydride plus H2O to give, let me, there's a 2 year and there's a 2 year. So the ionic hydride can react with water to give hydrogen. So you can use this method to produce hydrogen, but it is very expensive. So the second type of hydride are the covalent or molecular hydride. These hydrides are formed when hydrogen reacts with non-melters. Example of covalent hydrides are HCl, H2O, NH3CH4. So these are usually gases, although we have some liquids like hydrogen fluoride and H2O. So those are liquids because of hydrogen bonds. But most of them are gases and they have very low boiling point. Hydrogen can also form covalent bond with some special elements like boron and aluminum. So these are electron deficient elements. So boron, we can have boron hydride and aluminum hydride. So that's for the covalent or molecular hydride. The third type of hydride is the metallic or interstitial hydride. And these hydrides are formed when hydrogen reacts with transition melter. Well, it doesn't actually react. What actually happens is that hydrogen, because of its small size, is capable of filling the gas between the crystal lattice of these melters. So it doesn't really react with the melter. And these melters are very unique in the sense that they are non-stoichiometric. Meaning they don't have a fixed metal atoms to hydrogen ratio. For example, we can have TiH2, we can have TiH 1.8. So they don't have a fixed metal atoms to hydrogen ratio. So they are non-stoichiometric. So that's pretty much about hydrides, and that's the end of this video. Thanks for watching.